Welcome to our webcast, Ethernet Hardware. I'm your moderator for today, Mark Hosky, and I'm happy to join you on behalf of Control Engineering. Now I'm happy to introduce today's distinguished featured speaker for the webcast. Kurt Forster is an industrial control systems specialist with AutoPro Automation Consultants, an automation engineering firm that specializes in the design and implementation of industrial automation solutions. He has significant experience in all stages of system development and support life cycles, including design, development, installation, and administration of Microsoft Windows and Ethernet network infrastructures. I'm Mark T. Hosky, webcast moderator and content manager for Control Engineering since 1994. Before we continue, please take a moment to remind yourself about dealing with technical issues during the presentation. I'll pause briefly here. In October of 2013 and in November of 2014, Control Engineering conducted research on mobility, Ethernet, and wireless. The 2014 results 2013 report. The full report. I just want to share a few key points here. Products most commonly used, purchased, specified, or expected to be within the next 12 months were switches, wire and cable, networks, connectors, and routers. Among other products were cord sets, gateways, infrastructure, hardware, and software, along with services. Spending on product and services for Ethernet and productivity are closely correlated in the mind of the respondents. 40% of respondents expect to spend more on Ethernet, and 40% expected to increase productivity as a result. Also, around 40% expected to spend about the same amount on Ethernet in the coming year and get about the same amount of productivity. Ethernet has become part of the fabric of controls, automation, and instrumentation for most survey respondents. 46% of respondents see Ethernet as highly integrated with controls, automation, and instrumentation, and 40% see Ethernet as somewhat integrated. Just 12% said not very integrated, and only 3% said they weren't integrated at all. Most respondents, 42%, said Ethernet was easy with plug-and-play capabilities. 37% said it was more challenging, requiring some configuration. 14% noted some difficulty, and 8% had a rough go of it or gave up or required help. Data access is the greatest technology benefit of Ethernet by a wide majority, 63%, compared to the next benefits, which are ease of use and productivity gains, cited by about 37% of respondents. Many other benefits rate in the double digits, including cost savings, time savings, better asset management, less downtime, more effective maintenance, more accurate decisions or processes, greater accountability, and greater security. What stands in the way of wider adoption of Ethernet technology? Security and lack of training and education rank the highest, followed by budgetary issues, lack of use cases, and lack of a strong set of business cases to support the investment. Control Engineering looks at research performed by other organizations as well, including ARC Advisory Group, which recently updated its Worldwide Industrial Ethernet Devices report. The report covers wireline industrial Ethernet devices used below the controller level for industrial automation. It doesn't include wireless devices, dedicated safety networks, which are included in a separate report. ARC forecasts that this market will grow at roughly 20% compound annual growth rate for the next 5 years, significantly faster than the overall process automation or factory automation markets. Market drivers, they said, include greater recognition of business benefits, common infrastructure and network technology, advantages compared to serial communications, and a communication facilitator for Industry 4.0 and Industrial Internet of Things initiatives. ARC Advisory Group recommends that suppliers and end users should keep these factors in mind when deploying Ethernet products and technologies in these applications. They looked at focused value proposition, speed and bandwidth, discrete versus process applications, remote access and monitoring, connectivity, preparation for Industry 4.0 and IoT, as a connectivity tool to fuel critical business drivers, tailoring the value proposition beyond production, and as a cybersecurity strategy. Now Kurt will offer his advice on Ethernet hardware based on his project experience. Kurt?
Thank you very much, Mark. Hello, my name is Kurt Forster, and the aim of my presentation today is to assist you and get you to succeed in selecting the right Ethernet device or devices for the integrated control systems you'll be planning, developing, modifying, or just administrating. The slide reference here, the reference slide in this presentation will hopefully guide you onto how to choose the devices in the integrated control system. I will try to get you to understand why it is important for early participation during planning phase of projects, why and who decides the type of infrastructure the client will adopt. We will also learn about administrative responsibilities of the industrial infrastructure and why issues arise when choosing vendors and devices. By understanding who controls the industrial network segments during the project phase, you can identify the project leads who will be your contact point to the stakeholders. The leads should deliver policies and procedures, specifications, and requirements for devices in the project scope. Administrative groups will normally define the types of specifications and existing devices around the infrastructure. However, in projects, existing administrative groups are rarely in the decision-making process. This is why identifying the existing admin groups and questioning them will give you better chance of success in choosing the right devices for the infrastructure. This is vital information when performing site assessments where you can identify devices which have not or do not comply to your current specifications and requirements. By knowing the site specification and layout with the planned infrastructure into the existing infrastructure to investigate the health and security of the systems, remembering to be non-intrusive and passive only. With the wealth of information that has been accumulated, it is possible to recommend and develop lists of hardware specifications and requirements for your project. It is important to investigate all hardware companies, their portfolios, and make a comparison of all the requirements and specifications against the device lists. Once the lists have been refined by requirements, functionality, and cost, there is a firm understanding of who makes it into the preferred vendors list. With this list, you can go back and select the devices as per the project requirements. Once the devices have been selected and purchased, it is time to move forward and construct the infrastructure in a lab or staging area. This allows configuration and testing of the equipment. After the hardware and functional test, better known as a HAT, have been completed against basic configurations, it is advisable to bring the client in to perform the factory acceptance test, a FAT. Other testing and configuration happens up to the SAT and ISAT, which is the Site Acceptance Test and the Integrated Site Acceptance Test. This will be explained later in the presentation. Startups have different meanings dependent on the scope of the project. However, in this presentation, once all devices have been configured, backed up, and shut down, all configurations and securities should be done. The system should be ready for going live phase, followed by the SAT, ISAT, and the as-build stages. So, let's carry on. Introduction to Industrial Ethernet Infrastructure and Device Selection. An Ethernet-enabled device is a device that communicates with the IEEE 802.3 protocol. Commonly, these devices connect together by using an 8P 8C connector, also known as an RJ45, connected to a Cat5 or Cat6 cable. The IEEE 802.3 protocol basically allows the device to communicate over an Ethernet cable by encapsulating the packet in a framework and broadcasting it to other devices using the network interface card, or its NIC, via a MAC address, which is known as the OSI Level 2 communication. Because MAC addresses are not very user-friendly, people assign IP addresses to the device or communicate, which is a layer 3 functionality. So all layer 2 devices will communicate with a MAC address and ignore the IP address, but for ease of us humans, we define it by IP address. To make it simple, all I'm saying is anything with an IP address is an Ethernet device. Remember, simplicity, making it simple. For more information about the IEEE 802.3 standard, please follow the link. Throughout this presentation, I'll be using acronyms like the MAC, which is the main automation contractors, a MIC, MICC, which is the main instrumentation and control contractor, the IA or the OEM IA vendor, which is the industrial automation vendor, EPC, which is the engineering, procurement and construction, the PMC, the project management consultant, ICS, IS, which is the Integrated Control System and Information Systems team. It's a new acronym that you may not have heard of, and the FEED, front-end engineering design. Introduction to Ethernet planning in a project. Some may wonder why I'm talking about project planning when it comes to selection of Ethernet devices. Similar Ethernet projects from different manufacturers function differently depending on requirements in the marketplace. Standards, functionality, reliability, and manageability in relation to development costs define where the devices are placed in the marketplace. All this information needs to be understood when choosing the Ethernet device vendor in relation to choosing to the chosen infrastructure architecture and the vendors to supply the devices. Through experience, I know by introducing the infrastructure architect too late in a project can cause the client several $1 million in project creep. This was due to not having the infrastructure and devices correctly defined for the whole project. By not understanding this, the project budget can be blown very quickly. I personally would introduce the MAC or the MIC, or if the project has an OEM IA as the MAC, in the PMI second phase, which is the project definition and planning feed phase. By doing this, the CapEx project development time, specification changes, and scope creep will possibly be avoided. It is important that an agreement document between the MAC and the EPCs is developed, stating that all EPCs have to follow the project preferred vendors list for Ethernet devices. What and who defines an infrastructure? Finding out who and what defines an infrastructure is very important, as this will alleviate issues down the road. Understanding that large OEM IA vendors have very specific set of standards, and this list of Ethernet devices that are specified for their applications and network infrastructure. So during development, the IA owns the network architecture and the devices running on it. For third-party networks, find out who the owners are, as they may also have hardware requirements. When network segments are not owned by the MAC, they need to be defined and delegated to a MAC. Most companies have standards for Ethernet devices that are part of packaged solutions. Finding out who controls this is a daunting task. Within the end client's company, you may come across different departments who have different vendors and equipment lists. Like the ITIS Enterprise Department will normally have a different device list from the ICS-IS Automation and Control groups. It doesn't end there. Dependent where you are in the hierarchy of the EPCs, the MACs, IAs, and the MIC, you may run across that the EPCs, with their own one-stop shop packages, will only certify their packages with certain devices. These devices may be unmanaged devices which are from local electronic shops. It is very important when choosing a vendor and devices that you know what industrial network infrastructure standards are or what have been deployed. Most brownfield networks are sold that many of the standards that are currently out being used today were not around when they were being developed. Many standards like the IEC 62443, previously the ISA 99 standard for industrial cybersecurity, and the ISA 95 standard which explains how to divide devices into a purview level from the field up to the enterprise, are being used. Besides industrial standards, the end client, the IA, the EPC, the MIC may also have policies and procedures of how devices must be connected and how communications must be modeled. What is the backbone of the infrastructure and how is it built? Will you need to use 4G wireless or 10 gigabit over fiber? What is the point of having a remote location that are geared up to communicate at 1 gigabit when the backbone only supports 20 megabit over wireless? The last thing that will define the infrastructure is the roadmap of planning lifestyle for the plant. Most plants shut down for a few weeks or for a few months over a 5 to 10 year period. So changing out or migrating the systems need to be fluid, and in most cases done outside of the shutdown period. It is important that devices that are chosen are able to last 5 to 10 years with support from the manufacturer. Understanding administrative divisions in a company's and/or project. In this diagram, you'll see that I'm using the ISA 95 purview level of segregation. What you may not recognize is the ISA 95 Level 1 and Level 2 that has been divided into 3 separate communities. These 3 communities are divided into networks that are segregated by the following rules. The primary OEM IA, which should be separated from the EPC packages because most OEM IA SCADA companies only really support their own line of products. This is the same for the control networks that feed the SCADA systems. If the safety system is not purchased by the same OEM IA vendor, or if it isn't an integrated control and safety system, it should be segregated. Your EPC packages and third-party HMI and Ethernet devices should be in their own network, and supported for these devices come from the ICS/IS automation teams. By using these rules for your Level 2 and Level 1, you can divide your list by vendors of who owns the networks during the project phase. However, once the project is over, who administrates these networks? Normally, it falls to 2 Ethernet administration groups. One is the OEM IA support services, and the second is the ICS/IS administration team or the enterprise IS/IT. At the end of the day, these are 2 teams with who will most likely be decision makers on what vendors will be used. Explanation of the administration groups. The OEM IA. These are normally major SCADA control vendors who tell the client what hardware they will be installing. They are the best administrators in the service group for the networks. They are normally medium or large-scale installations. ITIS is the enterprise administration group, who are IT specialists that work on enterprise solutions. Industrial environments are considered backward architecture by some of these teams. Many do not understand the reasoning of having infrastructures that are running 10 years behind current enterprise standards. The ICIS are a group of ITIS savvy specialists or engineers who have known a lot about the control and safety and PLC systems. The main focus is concentrating on the protection and health of the safety, control, and SCADA networks. They are also in charge of and control the SCADA Windows domain infrastructure. The automation and control team are typically engineers whose sole focus should be around the SCADA application and the control and safety devices and applications. These systems basically run the plant and the process that are supported by the ICS and IS teams. Defining the infrastructure devices. Defining the devices by administration groups. Once you've identified the end administrators group, it is important to work with the administration or project administration groups to define what devices and capabilities of the device should be by breaking these down into device roles, specifications, and requirements for third-party networks and packages, Level 3 DMZ boundary and remote access, control PLC, DCS, IS, SDS, wireless and other networks like CCT and point of entry. They then also look at computers, servers, storage devices, and virtual host platforms, and any specific network devices related to them. The site assessment. The site assessment is a key, and it should always be performed by the infrastructure architect or a similar qualified person. They will assist the they will assess the physical locations and its capabilities and shortcomings. From this, they will also be able to define devices that may or may not be used. Some things that are looked for when doing a site assessment. Site location. Have a look around the site. What is it? How old is it? Is it a greenfield or is it a brownfield site? Or is it going to be a greenfield site which is connecting to a brownfield site? Will expansion of the site be needed? What is the ecological impact of the expansion of the site? What are the power resources and what can it supply? How will the devices be secured? What is current or future cabinet or enclosure space required? What are the HVAC requirements? What is the UPS solution? Redundancy and disaster recovery or the infrastructure. Most importantly, what are the hazardous zones and classifications of the site? And has it changed since the originally being installed for a brownfield site? It is also a good time to track all cabling, strange unidentified devices, and confirm the standard of fiber and patch panel cables. The infrastructure assessment. After the site assessment, the network infrastructure assessment is required to be done. This should only be done with current running monitoring applications and software or passive-only devices. Any active applications or software has a high chance of crashing PLCs, RTUs, or control networks and should not be used. This investigation will gather device scripts and configurations, information gathered from switch packet error logs on a per port basis, and as well as device system logs. Network security and quality of service settings based around password, port, and access security, as well as protocol and packet modeling. Patch, iOS, and firmware levels of each device. This data is vital to understand the age, health, and complexity of the existing infrastructure. If the network that is being built is a greenfield site, then you must understand that you should be looking to develop a system with a monitoring application that can take SNMP and syslog data and convert it into more human-readable format. How is this done? How this is done is via monitoring of your network and computer infrastructure health and performance. By using the built-in MIBs, which is Management Information Base, that is accessed by SNMP and is passive only for each device. It is important that each device has a MIB database and that the device uses the SNMP v2 or v3 if possible. If the OEM IA uses an SNMP or monitoring network device for health, then it is important that you do not change the RO or read-only read-write password, as their application will fail and alarm. However, it is very important that you know the read-only and read-write passwords for these devices so you can use them in your own monitoring. The OEM IA monitoring is their application and only for their branded devices and not for the whole infrastructure. Device specifications. Using the wealth of information we have gathered, it is important to make a list of devices specifications that will span the whole infrastructure and device zones in the infrastructure. The device specifications list should highlight the bulletin points in this presentation. Look at the slide and you'll see the points brought out there. By using HTTP or HTTPS to administrate devices, it makes it easier, but understand this: every mouse click is linked to a line of code that will change the device settings. The code that changes the settings may also change other settings in the device. Is it a code or is it a macro? Experience shows that web interface changes cause issues with running script by importing other commands that are not required, causing the network to stop or fail. Be very careful. It also opens devices up to be attacked, as the web browser engine in the device is very rarely updated in the Ethernet device to handle new web browsers. A more secure method to administrate devices is via SSH. However, this means your administration team must understand device language and line of code to administrate the device. Keeping networks secure and running is important. You must understand that the more backdoors you open, the easier it is to attack, and with administration on control and automation networks, at a bare minimum, these vulnerabilities will be open from day one. By looking at the firmware releases of a device, you can understand an update one's device is not a priority on some manufacturers' lists. If you have a release of version 1.02 or version 1.09, for example, over a 5-year period, then you know that these companies do not invest time in updating the bugs, holes, or improve their features in their firmware. Ethernet device selection. Make a list of all the devices from the architecture drawing with a list of specifications and requirements for each device. Go to each product vendor's website and add vendor's name and products that fulfill the specification requirements. In the list, add a number to each vendor for the device of how many items the device does not fill. At the end of the exercise, you will have a list of devices and vendors that can supply what you require. Many end clients are very concerned with cybersecurity and consequences of an attack. Make sure security features comply with the ISA 99 or other client standards or industrial standards chosen for the network infrastructure. It is important to understand the following when choosing devices: power and temperature ratings. If the devices reside in a very hot location or a very cold location, you need to make sure it covers that, especially if it is inside an enclosure which has no vents. Do you need to have 12 volt, 24 volt, 120, 220, 240, 360 volt, and do you also need to have a 3-phase power system? Different infrastructures have a requirement for different power phases for the size of the equipment. Will the device fit into existing brownfield enclosures and cabinets? If not, it is cheaper to change the device than having the cabinet or enclosure changed. Make sure you confirm and not assume that media will be what media you'll be using. A lot of devices come with fixed port media 100 FX ports. This is great, but if you only have single mode fiber in the location, then these devices are useless. Very important is the hazardous classification and zoning requirements of the device. I want to strongly emphasize that it is very important that the infrastructure is built to have as few points of failure built into it. Every Ethernet fiber cable, power source that is on the device is a point of failure. So it's very important that you design the infrastructure around not using or accepting media converters, terminal servers in the system. The biggest nightmare I've always come across are media converters and terminal servers. Only use these converters as a a last-ditch resort. Because we stated that Ethernet devices are anything that communicates on an OSI level, layer 2, we're also talking about storage devices, computers, servers, and now switches that also have the capability to be a virtual server inside the chassis. There are industrial certifications for devices, but make sure they fit into the budget constraints. Choosing the vendor. Look at the list and make that was made with all the devices, run through the list and group all the devices by vendor name and minimum points scored. Remove vendors and devices that have maximum points. Confirm that all devices are still covered by the vendors and devices in the list. Congratulations. You now have a preferred vendors and device list. However, look at what the current device budget is and compare it, remembering that not everyone can have a Rolls-Royce design. You may need to look at a lower device score. While making the list and scores for the device, it is also important to know what support services and product vendors can supply, as this may change the vendors list. Many medium and large companies will require 24/7 support and next-day replacement service, especially when you're running a plant that cannot be shut down. Do the vendors in the list have live help desk, technical advice centers, and what are the timings and loops that you have to jump through to get support? I've jumped to the testing phase before the installation phase because there's 2 stages of testing, pre and post installation. Pre-installation is broken down into 2 configuration stages, alpha configuration and beta configuration. Alpha configuration is normally work that is done in a lab where you get all the concepts of the configuration into a device, but it can be completely changed dependent on the infrastructure design changes. Beta configuration is normally done at the staging area and is the end configuration with no design changes planned. In a lot of cases, this is also the first time the administration team will get their hands on most of the equipment. Factory acceptance tests, FAT, are normally done in the staging area, which allows the end client to come in and test the functionality of the devices and the configuration. It is important that as a Mac, EPC, IA, ICS, IS, make the FAT tests specific to the scope of work developed during the planning phase. It is important to let the client see that from the specifications they delivered, they are getting what they ask for. At this stage, clients may go away, come back with scope change. Make sure the project manager knows as soon as possible and do not agree to changes without the PM's input. The IFAT may be new to you, but is an important second FAT test. This test is normally between the IA network, Mac networks, the IA network and the Mac networks. These are normally 2 separate project scopes inside a larger project scope. This is a very important test for the client and the Mac IA. This test will make sure that the device scripts and configurations work between the 2 networks. There may be configuration and media compatibility issues, so devices may need to be changed. This will be the PM's choice and it will affect one of the project budgets. Post-installation configuration is done on site and is the fine-tuning of device configurations. In many projects, it is the first time you get to test with EPC packages. Normally, the post-installation configurations should only be a fine-tuning of the devices to get the scripts to an end state. This will be a confirmation and tweaking of QoS bandwidth and packet modeling exercise. It is also to confirm ACLs and group rules in a layer 3 switch and firewall. It is also confirmation of the conduit protection and security for the ISA 99 zones. Once the fine-tuning is completed, then it is time for the Site Acceptance Test, SAT. The SAT is to be a comprehensive test where everything in the requirements list is tested. Also, fault-tolerant and simulated power failures should also be tested, and the recovery of the network is to be tested. Network failures by removing cables and confirming all fault-tolerant, high-availability routes are tested. Testing of error logs and error notifications should also be done at this point. It is very important that the customer signs off on the SAT, as this is the indication that the project can be finally closed and paid for. If anything fails at the SAT, take it to one side and get them to sign for the SAT with the understanding that the following items will be completed before the final payment is done. There are two types of ISAT. ISAT 1, which is where the SAT between the IA and the MAC is done. This is done before any systems are live. This is to confirm that the communications and data is being transferred, and it should be between the two networks. The ISAT 2 is the most complicated SAT type of SAT. This SAT is normally done on live systems and is to confirm the project has been integrated into the running plant and that the client's ICS-IS automation, operations, and maintenance teams are happy with the integration. Make sure a strict scope of testing is laid out and confirmed by the PM, as this is the last 10% of a project, and this can potentially break the bank of the project. Installation. During the installation, it is important to understand you are testing the hardware and and not the configuration. Make sure the hardware cabling power is running. Make sure all hardware cabling and power is running correctly. Trip the power to test to see the devices can handle a failure. Make sure the UPS and power sources can handle the load when all devices are turned back on at the same time. Confirm that the network cables are correct and that the cables are connected to the correct devices that are in the configuration list. Never start your configuration at this stage. Normally going from installation to live status is done within weeks of each other. Do not do any design engineering at this stage. That is for the lab and staging. Most importantly, make sure all health and safety precautions are taken when dealing with the end devices. Make sure all work done to the devices is listed in work permits. Make sure you have a contingency plan for device failures. Anything you do at this stage, make sure you have a rollback plan. It is too late at this point to be troubleshooting poor configurations, as you're now into the last days and weeks of the construction to a live state. Remember that on brownfield sites you may be working with in the same cabinets and areas as live systems. Always think before you do anything. Could this trip the plant? Startup. Startup is normally the time when all devices have been shut down after the final backup, and one of two things happen. One, connect the device to the live system and bring the network up on devices at the time. Connect the devices to the live system and bring the network up one device at a time until the whole network is up and running. Make sure the Windows devices and other applications are still switched off during this network startup. 2. Keep an air gap between the network that is starting up and any live systems until it is up and running and confirmed to be working correctly. Startup is the most nerve-wracking experience, especially if you're on a live plant. Whatever you connect could potentially trip the plant. Make sure you write out the procedures of the startup and plan it in phases. Start up one device and wait. It can be hours between each phase or even days. Make sure there are tests at the completion of each stage of the phase. Confirm configurations, confirm connectivity, and confirm functionality. Always have a roll plan and make backups before and after each configuration change. Write what you did at the time of, write what you did and timestamp it. Always start on a Monday and never end on a Friday. Always work through the weekend until it is completed, or roll back. Never have a half-started system, as this is a formula for disaster. Plan to always finish on a Wednesday, as this gives you 2 days of troubleshooting. Errors never normally occur on the day of installation, but a day or two later. This is because systems have had chance for its caches to fill and error logs to overflow, causing system crashes. Only proceed to the next stage once happy with that stage. Do not be afraid to roll back. Always have a cutoff point set to roll back. Trending devices. Throughout this presentation, you may have noticed I have not fixated on any one device or vendor. There are too many variables to apply to any one device or any client. No two clients are the same. Decisions on devices always depend on budget and the project. High-end devices will, with lots of functionality that require more configuration and management, are normally the most flexible and the best devices to go for. However, these devices are only viable for experienced and knowledgeable administration teams. This is normally the ICS/IS administration team who deals with these infrastructures. The pros of high-end devices: high configurability, robust, and have lots of after support and normally covered by corporate service agreement plans. The cons: specialized administration teams and administration equipment, license agreements required to work with the enterprise IT/IS to arrange service plans. Mid-range devices are usually very close in price to high-end devices, but are limited to the configurability and functionality. Pros: easy administration, so does not require specialized administration teams. They are slightly cheaper. The cons: limited configurability and functionality over high-end devices. Limited configuration knowledge when not using HTTPS or HTTP protocol. Low-end devices. These devices are normally just above non-managed devices, but are very cheap and limited in functionality. The pros: they're cheap, very easy to configure. Cons: very limited functionality. Maybe buggy, minimal or no firmware releases in the past 2 years. When you find trends, where you do find trends today are in device groups. These are groups of devices that supply specific function in a network. Industrial cybersecurity is a really key factor in today's infrastructures. Industrial firewalls, layer 3 switching and access control lists, IPS/IDS devices, control firewalls that specifically protect PLCs, controller, and RTUs, and normally reside at the ISA 95 level 1, are trending at this moment. In summary, Ethernet hardware and project advice. Selecting hardware devices is not as easy as picking up your local discount superstore catalog, where you can leisurely browse until you find the right device for a project situation. Selecting the right device for the project is hard, and there's a lot of hoops that need to be jumped through to get to the right vendor's portfolio. You are always to choose from. The only easy way to have devices chosen for you is to work with or ask a major OEM IA vendor who will tell you what you must have to suit their SCADA applications. The MICC are the same, and in some cases EPCs tell you what devices you must have. If you are the client and going into a project, tell your EPCs, PMCs, and MACs who your preferred vendors are. Give them the requirements and specifications for all devices. Generally, if you do not supply a list, they will give you unmanaged or a mixed pot of devices you as a client will need to spend money on and replace in the future. These devices make the environment unsecure And to make it secure and to get them working correctly, you will need to spend money. Thank you very much. My name is Kurt Forster, and it's been a pleasure presenting this webcast to you. I will now attempt to answer any or most of the questions that are out there.
Great. Thanks, Kurt. Appreciate the presentation. A lot of good material presented in a short amount of time, and we do have a lot of questions. People can go ahead and submit their questions. We're going to wrap up at the top of the hour. You can type questions in the Ask a Question box on the screen, and we'll get to as many as we can. Within a few days, the presentation will be available for on-demand viewing, and we'll post the archive on the Control Engineering website and send registrants an email message with a link to it when that and related resources are ready. I categorized the Ethernet hardware questions submitted by registrants before the webcast as of last week. The leading topics were design, switches, protocols, troubleshooting, security, and power over Ethernet topics. Now on to the questions. Can hardware selection help network security, and how?
Yes, it can. Network hardware selection, if you try to divide your network into access control lists or layer 2 switching, there's no way of really being able to configure your environment around modeling your data. So what you need to do is bring in, and as a hardware selection in this case, is bring in things like firewalls, control firewalls. Control firewalls are fairly new and are becoming more and more popular. By doing this, if you think of an ISA 99 environment, you have data zones, and you connect the data zones by conduits. The conduits are your network paths, basically, and you need to protect the ends of the two network paths with hardware. With your ACLs or firewall groupings of protocols, and that can only be done within in a hardware.
Great, thanks. Several questions asked about industrial Ethernet protocols' influence on hardware selection. Could you address that briefly?
Industrial Ethernet protocols, if we look at Ethernet protocol, as I said, that is the IEEE 802.3 protocol. That is basically what an Ethernet device is. But the other protocols, what you're talking about here, can influence on hardware selection. There is Ethernet over IP, which certain devices can be used. These devices are only supported by some of the vendors that are out there. So if you're going to be using these protocols, you have to make sure that you select the devices, and part of the whole research is what we were doing, as I explained it, will identify those devices that are able to work on those protocols.
Great, thanks. Several questions asked about interoperability. Could you address that quickly?
So interoperability, for example, you may have two switches and they use a fiber port. One of the fiber ports may communicate on one bandwidth and another one is on a different bandwidth slightly adjacent to it. Now the interoperability in that case is the wavelength difference between the two devices. This can cause black spots in the communication, which causes a rebroadcast. So you're not exactly getting what you need through or the services you need between those two devices, which may be from which would be from two different vendors.
Troubleshooting and diagnosing network-related problems was a big area for questions. Do you have any tips in those areas?
Basically, troubleshooting. Just think of it as the KISS acronym. Go right back to the very basics. Where does it start? Where are you getting the issues from? Go and go right back to your network cabling. Everyone may think that their network cable is perfect. Have a look at the ends. Is it a factory terminated cable? Is it a man-made on-the-spot cable? Going down to the device, are there error logs? Go into the device, have a look at the error logs. Look at where the error logs are coming from along the point-to-point of the communication. And start from, make it very simple. Don't go and attack where you think the device is, because everyone knows if something is happening within a control system or an application and they can't find it in the application, they always blame the network. And because they always blame the network, they always say it's that. So if you need to troubleshoot in that sense and you're getting issues, go through each device one at a time, looking and comparing it against your documentation. Documentation is one of the most important things about your infrastructure. You should always have the documentation to compare against when you're troubleshooting.
Great. Thanks very much, Kurt. We have a number of other great questions. Kurt has volunteered to get to those offline. We'll post the answers to those questions with the ancillary materials for the webcast. So we'll get after those as quickly as we can. We appreciate the great questions from our audience, and thanks again to our speaker, Kurt Forster of AutoPro Automation Consultants, for sharing his time and expertise